Now let's look at some rules for simplifying sigma notation. And these are kind of similar to like rules for limits or derivatives and integrals. Very similar to that. So like there's a sum difference rule, which means if I have a sum of, let's say, A plus or minus B, where these are A terms and B terms, then what I can do is I can break that sum up over the sum of A and then the sum of B. Okay, so you can do those individual sums, and just add the sums, the individual sums. Similarly, there's a constant multiple rule. So this is where C is a constant. So if you have some constant times the A terms, A k terms, A sub k terms, then what you can do is you can pull the C out of the sum like this. You can pull the C out and then just do the sum of the A terms and multiply it by C. And you can actually see these rules. Like this is because addition is commutative, and even subtraction because you're taking the sign with it. Okay, so you can switch the terms around and just add them up individually and then add and subtract them. This here is because multiplication distributes over addition. Okay, so you can pull the C, like this would be a factor, and you're factoring it outside of the parentheses. Or doing the distributive property in reverse. And then this one here is, okay, this is the sum as k goes from 1 to n of some constant c. So this was like the one we did in the last video where I had k equals 1 to 4 of pi over 2, and pi over 2 was a constant, and so we just added it together 4 times. So basically if it's 1 to n, then you're going to add c together n times, and so you can find this by taking n times c, and the product there will give you the sum of those. Okay, so let me show you then. So this thing could be simplified here. If you have this expression, I could first split it up over that difference. So k equals 1 to the n 3k minus the sum of k equals 1 to n of k squared. So it would look like that. And then what you can do here is you could take the 3 out. So you get 3, and this would just be k. So this would be k equals 1 to n. This would be minus, and then here, there's nothing I can do here. I can't break it up over a product or take an exponent out or any crazy thing like that. So this would just be equal to k equals 1 to n of k squared. Okay, so this expression can simplify into this. And then if I had formulas for getting the sum of the first k terms, you know, where this was like 1, 2, 3, 4 on up to n, if I had a way of getting that, then I could plug it in there. And if I could get the sum of the first k squared terms, like 1 squared plus 2 squared plus 3 squared plus 4 squared, if I had a formula for that, I could plug it here and then actually calculate. I could put the two things in there and calculate what this sum would be. Okay, so what I'm going to do here is show you kind of what I mean here. Let's say the sum of the from k equals 1 to 10 of k is 55, and it actually is. You can add 1 plus 2 plus 3 on up to 10, and you will get 55. And then the sum of k equals 1 to 10 here, that should be 10. It is 10, but it doesn't look like it. 1 to 10 of k squared, so this is 1 squared plus 2 squared plus 3 squared on up to 100, or 10 squared. Adding those up, if you do that, you get 385, and that's actually what you'll get. And so let's say you had formulas for getting those, okay, where you could put in the number, however many terms there were, let's say n terms, k equals 1 to n of k, and you had a formula in terms of n, or k equals 1 to n of k squared, and you had a formula that would give you the first n k squared terms, right? Then what you could do is you could figure out something like this. So this thing here could be written 2 k equals 1 to 10 of k squared minus 3 k equals 1 to 10, and this should be a k here, of just k. So what I'm doing is I'm breaking this up over the sum and differences, and then I'm pulling the constant multiples out. Okay, and this would be plus, this would be k equals 1 to 10 of 5. Okay, so I'm breaking these up, and then the constant multiples you can pull out, and then I have these sums up here. So this would be 2 times 385 minus 3 times 55 plus, and what would this be? 1 to 10 of 5. So there's n terms here. So you would have 5 times 10, or 10 times 5. Okay? So I could probably do this in my head. This would be 700, and then 35 and 35 is 70, so I think that's 770 minus 3 times 55 is 165 plus 50, so this would be 770 minus 115, and so that would bring it 670 minus 15. Okay, 600. If I did my math right, 655. Okay, so so that's the idea here. Now, what I want to do in the next video, we're going to show you formulas for these here. But before I do that in the next video, I want to share with you kind of a fun story from the history of math. This is kind of math lore. If you ask the experts who the 3 greatest mathematicians of all time were, what I've heard is people will say Archimedes, Isaac Newton, and a guy named Gauss, Frederick Gauss. And Gauss lived, I think, like during the maybe 1800s, and he was a child prodigy. And he had a tutor that wanted to keep him busy, and he was like a 5-year-old child. And so the tutor said, add up the numbers from 1 to 100. 1 plus 2 plus 3 plus 4. And he was just wanting to keep him busy. He said, go ahead, add those up, and when you're done, let me know. And he thought that would keep the child busy for a while, maybe 20 minutes, 30 minutes or something. But like 30 seconds later, the child came to him and said, here you go, here's the sum. And he was right. And here's actually what he figured out. This is what he did as a child, is he took and reversed the numbers like this. So and he realized that when you did this and you added all these up, this would be 101, this would be 101, 101, 101, 101. And he realized you had 100 factors of 101, and he knew you could add the 2 zeros and you would get 1,100. But he knew that when he did this, he ended up adding 1 to 100 twice. And so all he needed to do, 1 plus 2 plus 3 plus 4 plus on up to 100, is to take this number and divide it in half, which was 5,050. And that's what you get when you add the numbers 1 to 100, 5,050. Okay? And this is actually the formula for this. So if you think about this, the sum of k equals 1 to 100, what this is here is 100 times 101 divided by 2, and you get 5,050. The one I did, k equals 1 to 10, would have been 10 times 11, because you would have reversed them and added them together. Each one would have been 11 this time, divided by 2, and then you get 100. You get 110, and then divide it in half, you would get 55, which is what that number is. And so this actually forms the basis of the formula that we're going to learn in the next video for the sum of the first in integers, in natural numbers, 1, 2, 3, 4, 5, on up to n, whatever n is. You can use this formula that we're going to learn in the next section. And there's a similar formula. I'm not going to derive this one. It's more complicated. But there's a similar formula for the sum of the first in k squared. And there's also one for the first in k cubed. We're going to learn those three formulas along with this constant formula. And we're going to be able to use that as you will see, to find the limit of these Riemann sums. So that's where we're headed with all of this. I wanted to show you one other thing too. There was an interesting one in the book. Let's say you have something like this, k equals 1 to n, let's say 1 over n. This gets a little confusing because in here, technically, k goes from 1 to n, but if this a term is 1 over n here is a constant. N is not changing. Once you have your sum, n does not change. So with respect to k, n is a constant. And so you got n of these. And so this would actually be n times 1 over n, which is just equal to 1. So this complicated thing reduces down to 1. And that's true because let's say if it's, let's say k equals, we'll say 1 to 3 of 1 over, and n here is 3. It would look like this. And so this is just saying 1/3 plus 1/3 plus 1/3. And of course that's equal to 1. And it doesn't matter what n is. If it's 10, it'd be 1/10 plus 1/10 plus 1/10 by itself 10 times, and you would get 1. Okay? So, in other words, in here, when you actually have a sum, k is the variable that's changing. Okay? And so, with respect to k, and with respect to this sum, 1 over n is a constant. Anything involving just an n is a constant. And so, for those, you can use this constant rule. Okay? And so that's an important thing to keep in mind. So in the next video then, we're going to learn these formulas we've been talking about.